Here is section 6.5, day 2, part 2, using the Pythagorean theorem. This section should complete the back of your notes, followed by the checkpoint and the end of the 4 questions. This is the last video for tonight's lesson.
So now we're going to use the converse of the Pythagorean theorem to check to see if this actually is a right triangle. Now you can see that the right triangle symbol is not located in the corner of our triangle because we're checking to see if it is. And then we're going to check to see if this one is. Don't always go by the pictures because that might mess you up by saying, nope, it's not. But you didn't actually check the numbers to see if it balances. So our plan is to use the Pythagorean theorem. We're going to check to see if those 3 values actually balance the Pythagorean theorem, and if they do, then we can state that this is a right triangle. So my plan again is to use a squared plus b squared equals c squared, giving myself a key. A is, now if we look at this, is our 9, b is our 40, and technically the longest side is c. So you got to be careful. Make sure that that longest number, whatever that is your c. So now I'm going to substitute. I have 9 squared plus 40 squared equals 41 squared. But I don't know if it does, so we're going to put a question mark over the top to tell the reader I'm questioning it, I'm not stating it is yet. So now I'm going to use my calculator. If you want to pull it out, that's fine. You're doing numbers that I'm not expecting to be memorized. So 9 squared, I am expecting that one, 81 plus 40 squared, which is 1600, is equal to 41 squared, which is 1681. We're checking, so again, you gotta put that question mark up top. We're not stating it yet, we're still questioning it. So now when we go down, we get 1681 is equal to 1681. It's no longer a question, it is. So 1681 is equal to 1681, so what's my conclusion? My conclusion is that this angle is a right angle. Therefore, the measurements of the triangle do make a right triangle. So we justified using the Pythagorean theorem that those 3 measurements balance the Pythagorean theorem, proving then the triangle must be right. We're going to do the same thing for this one. So my plan is to use a squared plus b squared equals c squared. My a is, now this is the one that I don't know. So if I look at my numbers, 18, 12, 24, which one's the longest length? That's automatically going to be your c. And hopefully you realize 24 is the longest. Automatically c. Then it doesn't matter for A and B because they're both legs. So I'm just going to use 18 and 12. C matters. So now I'm going to substitute. I get 18 squared plus 12 squared equals 24 squared. 18 squared is 324 plus 12 squared, 144, is equal to, I forgot it in there, that's where we're questioning it, is equal to 24 squared, which is 576. So now let's add the left side. So if we add these 2 together, we get, what do we get? 468 is equal to 576. No, it's not. Slash. 468 is not equal to 576. So the numbers we used for our A, B, and C do not satisfy the Pythagorean theorem. If they do not balance the Pythagorean theorem, then this triangle is not a right triangle. It's still a triangle, but it's not classified as a right triangle. So I would go back and say that, therefore, the measurements of the triangle do not form a right triangle.
Here's the checkpoint that goes over the converse of the Pythagorean theorem. Please make sure you're using the correct measurements for A, B, and C, and you're questioning if they actually balance the equation.